Okay, so we're starting section 4 here in chapter 12. And today is going to be just a lot of information sharing about what solids are, what are the solids that we're going to be studying here in this class. So first of all, let's start off with the definition of what a solid is. A solid is just a 3D shape that's formed by intersecting planes. And we're going to spend most of our time in this unit talking about 4 main types of solids. Prisms, pyramids, cylinders, and cones. We may touch on and spend some time talking about spheres, but this is predominantly where we're going to spend our time. The prisms is where we're going to start. And you can see from your paper and from what I have up here on the screen, there are several different types of prisms that we're going to discuss. And I'm going to show you some real-life examples of prisms, because prisms are the most commonly shaped item used for packaging, or the most commonly shaped box used for packaging. If you go to a grocery store and you walk up and down the shelves, predominantly you're going to see boxes that resemble prism shapes. Okay, so for instance, over here, like this big box that I have here in the corner that my projector came in, this is an example of a rectangular prism. Imagine a cereal box. I have back here, which I still haven't been able to bring myself to passing these things out because they're such a prized possession. These animal crackers, I'm sure the shelf life on these things is about 10 years, but talk about a non-perishable. But this is a rectangular prism, okay? You walk your cereal boxes, they all look like this right here, okay? Now, they don't always have to be this rectangular shape. You can see they might model or resemble a triangular shape. Now, the Kleenex box put this out years ago. This is one of those special runs that they had. I didn't see these. A student brought these to me. This is considered a triangular prism because you can see the triangle. But if I turn it, every other face is what? A rectangle, yeah. So prisms, when we get to the definition of them and the characteristics of them, you're going to see that it can have a non-rectangular set of faces, but predominantly the lateral area or the lateral faces are going to be rectangles. So that's an example of a triangular prism. Someone else brought this to me as well. Charlie Brown's Christmas tree. Okay, this was originally packaged. You can see that item right there. It looks pretty impressive. A student in one of my other classes says that he actually bought this for his mom for Christmas one year. So I can verify that it actually is being sold. This is not a very common packaging for products. You don't typically see this. But this is an example of a triangular prism. Triangle, triangle. You have your rectangle, rectangle, rectangle all the way around. Now, I did one time, I don't know how I got this, but this was sent to me. Maybe it was like a poster or something. Sometimes they'll ship posters and something like this. But this is an example of another rectangle or triangular prism. But I took this one because you can unravel it, and you can see exactly what it consists of, what it's made of. All right? So you see your 2 triangles at the ends, and then everything else is going to be a rectangle. Now, this triangular prism actually has excess to it. Like there's more, well, I shouldn't say more than necessary because this is a packaging, and we'll talk about that. But in order for it to be a triangular prism, we do have a little bit of extra. Do you see what might be considered extra here? Andrew? An extra rectangle. Yeah, so like imagine, might be easier, like imagine this rectangle right here. I don't need that rectangle right there to close it off. You can see I can close it just fine with this, but this is an extra piece. Now, because companies have to pay for this packaging, so whatever I got that was shipped in this, which again I can't remember, but whatever I got, the company had to pay to ship it. And the more material that you use to package it, the bigger the cost. So they must have deemed that this was still necessary, right? So why do you think maybe they have an extra piece in there? Because we're gonna practice, we're gonna pretend that we are packaging engineers at some point throughout this unit, and we're gonna design boxes for different objects. So why might they consider that? Devin? Yeah, that's what I would assume. He's saying for protection, for like stability. Exactly. If I go here, and that would kind of be a similar reason for protection. But yeah, if I just seal it there, then I'm going to tape it. It could come open. So this now has an overlap part to it, and you can see where the tape, the original packaging tape, went right there. So makes it sturdier. It will be less likely to open. But again, we're going to see that it's going to add cost to the box. But nonetheless, that's an example of one. Go ahead, Alex. Oh, like a trapezoidal prism? I used to have one of these. Sorry, bro. Yeah, they make them. I've seen them. They're very rare, but I have seen. Well, how about this? My blocks. So this shape here is considered a prism. This would be considered a hexagonal prism. See your hexagon? Okay. Every other face. Now, granted, we have a top part, so it's not, by definition, it's not exactly what a hexagonal prism looks like, but nonetheless, it resembles it. But every other face here, you're going to see is a rectangle. Okay. And we're going to, when we talk about the definition of these, you're going to see that this fits that description for that. Yes, Akash. What's that? Yeah, you could use, yeah. I'm not saying the only thing you can use is for that. I'm just saying the most common form of packaging would resemble some type of prism. Yeah. Okay. You don't have to do this, but if you ever think of it, take note of it. Like if you go into a store, like most of the items are going to be, think of like your toothpaste, right? Toothpaste come in boxes, most likely. Those are rectangular prisms or square prisms, depending on the ends of them, okay? So that's very common. The other type, next one, oh, pyramids. I don't know how many different types of pyramids. You see a couple drawn on your paper. I have what I would call a square pyramid. You guys know what pyramids are. You got a base, you've got the vertex at the top, but every other face on the pyramid is a what? Triangle, right? That's what makes it a pyramid. Now, how do you determine how many triangular lateral faces you have on a pyramid? Do you know that, Sarah? Good, exactly. So if I have a four-sided base, I'm going to have four triangles. If I have a five-sided, five triangles, this one here would only have three because it's a triangular prism, or triangular pyramid. Cylinders, next one. Here's, I just dug through my closet. An old coffee can. So I wasn't drinking coffee. I just have a ton of rubber bands in here. They're not to shoot at people. They're actually there was a reason I had them. All right. That's true, yeah. Well, anytime someone needs a rubber band, I get in there. It's like I open this up, and the kids are like, "Oh man, all the technology we have in the world today, it's amazing. You guys are just mesmerized by rubber bands." But whatever. Okay. So cylinder, yes. All right. Cylinders are pretty basic. There's not really different types of cylinders. A cylinder is a cylinder. You can have like different sizes of them, but it's not like you can have like we have different shaped prisms that can look very different from one another. Cylinders don't look much different. I did have another one. Got a stick here, a baton. All right. This is a cylinder, hollowed out, of course. So if you're talking, when we get into this, we're going to talk about how to make these and how much material goes into it. Something like this wouldn't require as much material because you're missing pieces to it. It's hollowed out versus something like this where you have to fill the whole thing in. So that's one of the jobs that we're going to have is to calculate how much cost is needed for these. The last type would be a cone, and you guys know what a cone looks like. Kind of like a cylinder. There's not much I can do with a cone. I mean, you have a cone, and it looks like that, okay? Bigger, smaller, but it's like a funnel cone. Looks like that. Okay, so let's get into the meaning and the description of each of these. So prisms, any type of prism, it must have two parallel bases. That are congruent polygons. The lateral faces, we mentioned this earlier, like on this triangular prism. We said you've got triangle, you got triangle. Everything else is a what? Rectangle, right? And I showed you that with the hexagonal one, the rectangular one, all of those prisms, every other face is a rectangle. Now, I want to clarify something in regards to the bases. First of all, I guess going down below here, prisms are always named for the shape of its base. So when I call something a triangular prism, that means the triangle is the base. But here's what oftentimes happens. When we start finding the volume of these types of figures, and I give you this right here, and the formula says, in order to find the volume of this shape, you got to take the area of the base, multiply it by the height. Well, a lot of people think that the base is the bottom, like what it's resting on. Like if I'm holding it like this, and I said, what's the base? A lot of people are going to tell me, well, it's a rectangle, because it's sitting on that rectangular side. And I understand that. I mean, base, you think foundation, but it's not. The base is always the non-rectangular part, if there is, in fact, one. Now, if I gave you something like this box, which let's just assume that these are not squares. I don't know that they are or not. But let's assume these are all rectangles. Then it doesn't matter, right? Any side could be considered the base because every face is a rectangle. But on something like this, it definitely matters, okay? So we always name it by its base. So the one on the left here, that would be considered a triangular prism. The one in the middle, since it's saying we have square bases, and that would be a square prism. For a cube, right? Is a square prism a cube? Good. It's not. Why not? What would be the difference between a square prism and a cube? William? Every face is a square, right? Exactly. It has 6 identical square faces on a cube. Rectangular prisms don't necessarily have to have that. Okay? The last one over there, that's what the blocks were all in there. That's considered a hexagonal prism. Okay. All right, let's go on to pyramids. Since we've already pretty much talked about this, pyramids have exactly one base. Yes, one base. And that base must be a what? Yaman? Could be. Doesn't have to be that. Could be. Sarah? Has to be a polygon. Yeah. So rectangles, squares, triangles, pentagons, hexagons, all of these are fair game. You could create a pyramid from that. And if you remember earlier, we said that the number of lateral faces, which we said earlier are triangles, the number of lateral faces is always determined by the number of edges on the base. So if it was a pentagonal pyramid, then you're going to have 5 triangles that make up the lateral faces. A pyramid is also named for the shape of its base. Now, pyramids, unlike prisms, typically do rest on the base, especially the ones you've seen in ancient Egypt, right? That would be considered the base. You don't see too many pyramids that are laying on, its side like that, okay? Unless it was what the other day when the wind was blowing so bad, all right? Typically, yes, when we say the base of a pyramid, it's usually the side that it's resting on, but it doesn't have to be. It would be the non-triangular face if there was one. So the pyramids here, the one on the left, that would be a rectangular pyramid. And the one on the right looks kind of rectangular, but maybe I'll tell you all four sides are equal like that and then call it a square pyramid. Cylinders and cones are pretty quick, pretty easy. A cylinder. Cylinder has two bases that are parallel congruent circles. The lateral area, meaning the non-base area of a cylinder, is what? So I have my cylinder here. So I'm talking about this rounded portion. What is it, Paige? It's a rectangle. Yeah, imagine like taking, well, even your notes or a paper and rolling them up to make a cylinder. The rounded lateral area would be still that rectangle that you started with, because when you unravel it, it's going to come back to that rectangular shape. This example right here, this is the net. It shows you that. It shows you what it would look like if it was unraveled. And that's going to be important for us when we learn how to find the surface area of these shapes here. Again, not much else we're going to talk about with pyramids, cylinders right now. And cones, kind of the same thing. A cone has exactly one base. We'll call it a circular base. So it's got the base, and then it's got one, I think I said it earlier. One, okay. Well, triangular circle, okay. I was thinking more, go ahead, Paige. Good, vertex, yeah, because when you have a circle, and then you got this point up top, that's your vertex. Now, I know what Akash is trying to say, because when you unravel it, the lateral area resembles this shape here. So you do have like kind of a triangle circle hybrid there, but we're talking about one vertex. Now, a couple of these fit into the category of something called polyhedrons. I know we got some odd names today. A polyhedron is a solid with a polygon for each face. So if we think about the ones that we just talked about, the prism, the pyramid, the cylinders, the cones, two of them fit this description. Which two contain only polygons or are made up of only polygons? Alex? Yeah, prisms and pyramids. Good. So you guys have a good understanding, a good back knowledge of all of these shapes. Now let's extend it to something that the first time through we didn't necessarily understand. Because when we did the geometry packet a couple of weeks ago, there was a question about cross-section. And I know that tripped most of us up, and I can understand why. Let's just define these two things, and then we'll talk about what they look like. So a plane, not the ones that fly, but geometrically, a plane is just essentially a flat surface that extends infinitely in all directions, like a wall that just never ends. And a cross-section is what happens when one of these planes will intersect a three-dimensional shape. It's like a slice. The analogy that I use a lot of the times is when you go to the deli and you order like some ham or some turkey or something like that. You guys have seen the slicer, right? They throw that thing on the machine, and then it just real thin slices of this particular meat, right? That slice, imagine that on a 3D shape. So if I ask you to find a cross section for a cylinder, for instance, imagine just slicing portion of it, and what two-dimensional shape would that create, okay? So I have a couple of examples here, but the best way to do this, I think, is to try to use my projector to help me out. You guys are familiar with like perspective drawing, right? Right? You know, you're far away, you can't necessarily tell like how big something is, or you lose that depth perception. So imagine if I use my cylinder here. The cylinder, if you were a long ways away, staring right at this cylinder, what might it look like to you from a long ways away? What might you see, Sydney? Yeah, because I did this like with my other group. So imagine, minus my arm here, I can't really let go of that. But like if you stood a long ways away, you can see that's a rectangular shape that creates from that, okay? So right here, when it says to find the cross section, imagine drawing the top and the front view of a cylinder. Well, this would have been the front view of the cylinder, right? This rectangular shape. So that means that the cross section, if I were to take and just slice vertically right down through this, like take one of those, that meat slicer like I talk about, cut it, you're going to get a rectangular shape. Now think about, what if I did an aerial perspective of this? So I'm holding it like this, and you're, you know, in a plane, or you got your drone flying over, whatever, and you're staring down. What are you going to see if you don't have depth perception? Sean? Yeah, it's like a horizontal cross section would just be, if I can do this without dropping it. I guess you guys can't really see it in the image there, but it's going to create a circle for that. So that would be your top view. So depending on how you cut this cylinder, you might create a vertical cross section that looks like a rectangle, or a horizontal cross section that looks like a circle. All right, let's go one more here. What about a triangular prism? So Charlie Brown. Charlie Brown, top view. Depends on how you're holding it, too. Okay, so let's just say I'm holding it like this. You guys would be experiencing the front view of this. It's hard for me to get this to be exactly the way I want it. Front view. What are you going to see when you see front view with no depth perception? Sarah? Yeah, you got your triangle. So that would be like your middle. So a cross section for this triangular prism, if I did a vertical cut, real quick, I get the triangle. Now what if I did an aerial view, the way I'm holding it now, imagine like over top of it. Yamin? Good. I have a rectangle. And then the last one, what if I went from like this side here, the way I'm pointing? Another rectangle, right? So you'll see that. All right, good. I'll see you guys on Monday.